Hello everyone, I'm Harshita Singanagari. Today I'm going to talk on the topic Understanding Normal Forms in Database Design. Let's see the definition of a normal form. Normalization is a systematic process in database design that helps to organize the data in a structured way to reduce the redundancy and ensure the accuracy. Let's see the purpose of the normal form. When a database is not properly organized, it may store the same information multiple times, which leads to the inconsistency, wasted storage, and the maintenance problems. To fix this, we apply different levels of normalizations called the normal form, each of which addresses a specific type of problem. Before exploring the normal forms, it is important to understand the data anomalies. These include insertion anomalies, when new data cannot be added because the other information is missing; update anomalies, where a single change must be made in multiple places and missing even one update causes errors; and deletion anomaly, where the information where where the in where removing one record unintentionally removes important related information. Normalization helps to eliminate these issues by structuring tables properly. There are different types of normal forms: 1NF, 2NF, 3NF, BCNF, 4NF, 5NF, and 6NF. These are some of the important normal forms. Let's see what is 1NF. The first level of normalization is the first normal form. A table is in a 1NF when all it includes the values are atomic, meaning each cell contains only one value, and when there are no repetitive groups. In the above table, the courses has a multiple valued attributes, so it is not in the 1NF form. So to make the table in a 1NF, we have to remove the multi-valued attributes from the table to make it 1NF form. So this is what the 1NF forms, and this is the table, and this is the structured one which follows the 1NF rule. Coming to the second normal form, which deals with the partial dependencies. The table qualifies for 2NF when it is already in 1NF and when every non-key attribute depends on the entire primary key, not just part of it. This issue mainly appears in the tables with the composite primary keys. Coming to the example, there are many courses having the same course fee. Here, course fee cannot alone decide the value of the course number or the student number. So, course fee together with the student number cannot decide the value of the course number. Similarly, it's like the course fee together with the course number cannot decide the value of student number. So, the candidate key for this table is the student number and the course number. Because so so the candidate key is student number and the course number. Because of this combination, these two columns uniquely identifies each row in a table. So the course fee is the non-prime attribute because it is not a part of the candidate key, which is the student key and the student number and the course number. But course fee, that is the course fee, is dependent on the course number, which is a proper subset of a candidate key. Therefore, non-prime attribute course fee is dependent on a proper subset of the candidate key, which is partial dependency, and so this relation is not in 2NF form. So in 2NF, we eliminate such dependencies by breaking the table into two separate tables: a table that links the student and the courses, a table that stores the course fee. So here we are dividing it into two tables, that is the student course table and the course table. This is what second normal form looks like. Coming to the third normal form. The third normal form eliminates the transitive dependencies. A table is in 3NF if it is in the 2NF and if non-key attribute do not depend on other non-key attribute. In this table, we have repeating groups of course and course instructor for each student name. To normalize this data to 3NF, we can create two separate tables, student table and the course table and the courses. By splitting the original table into two tables, we remove the repeating groups and achieve the 3NF. The students table contains the unique student information, while the course table contains the course details associated with each student. 3NF helps to ensure that the data is organized efficiently, which is efficient and reduces the redundancy and minimizes the risk of the data inconsistency. By following 3NF guidelines, database designers can create well-structured and reliable databases, relatable relational databases. So this is the example for the 3NF. And coming to the BCNF, BCNF is also called as Boyne's Code Normal Form, which is the advanced normal form. A more advanced level of the BCNF, which is a stronger version of the 3NF. BCNF states that any attribute that determines another attribute must be a candidate key. Problems that violate the BCNF are rare but serious. Candidate keys, here is an example for it, for the BCNF. In this, the candidate keys are student and the teacher and student and the subject. The above relationship is in 3NF. Since here there are no transitive dependencies, a relation R is in BCNF if for every non-trivial. Like so X depends on the Y, X must be a key. So the above relationship is not in a BCNF because in the and also here the teacher is not a key. This relationship suffers with the anomalies. So for example, if we delete the student Tara, we will also lose the information that N Gupta teaches C. This issue occurs because the teacher is a determinant but not a candidate key. R is divide. So what we do is like this R is divided into two tables, two relationships, that is the teacher subject and the student teacher. So that's how we divide the table, and this follows the BCNF rules where we can determine the candidate key separately. Coming to the assignment problem that we have done, here they have given a table which contains the lab code, patient's ID, lab results 1 and lab result 2, and also the code is a unique one, and it is also, so the question is like this, what did it violate? So yeah, here is the solutions I have taken out. So basically they have violated the first normal form because of the repetitive groups, that is the lab results and the lab results too. So it has a multi-values repeating attributes where it is not like singular or unique. So here they violated the first normal form. To avoid this first normal form, I came up with a solution, dividing, writing the each individual code. We have write the repetitive columns into a distinct rows, like a different rows, individual rows. So like it's like if we have 1 1 200 210, and so I have divided like this. So 1 1 1 200 and it's a 123, like this. So by dividing this into several rows, we can reduce the repetitive columns or duplications, and by dividing this we can make this atomic, and it follows a 1NF rule. This is all about the normal forms. And the benefits of the using normal forms is like the consistency increases, it reduces the redundancy, and also while managing the databases, it should have, when accessing any or retrieving any database, it should be fast and it should not show any duplications to us. So to streamline the database and have that efficiency in retrieving the data, we use the normal forms. And also for the better data analysis and reporting, for like for example, we can have a multiple rows and rows in the same database, which is not necessary, and which which can increase the data space. So to reduce all these things, we need to use the normal form to reduce or remove the duplications or reduce the redundancy. So we use the normal forms. This is all about the normal forms. Thank you.